Your email travels across the internet and attacker can potentially modify your email. So how does a receiver can verify that your email is not tampered with? The solution is DKIM. In today's video, we are going to learn about the DKIM. The full form of DKIM is Domain Keys Identified Mail. In the previous video, I already told you about the SPF. In today's video, we will learn about the DKIM, how it works. So let's deep dive into DKIM video. So DKIM is Domain Keys Identified Mail, and it is an email authentication protocol that uses digital signatures to verify that an email was actually sent by the claimed domain and that is its content have not been modified during the transaction. So when a receiver is receiving any emails from the sender sites, how the receiver will verify that the email that he is receiving is not modified in between, and how it verifies that it coming from a legitimate user? The answer is DKIM. So in a previous video I covered SPF. So SPF checks who sent the mail, sender's server or the IP, and DKIM checks whether the email content was changed or not. So that's the difference between the SPF and DKIM checks. Okay. So why do we need DKIM? As I mentioned in the definition also, let's deep dive into it more. So suppose your company sent this email from hr@thecompany.com, subject salary revision, amount is $5,000. Without DKIM, what can happen is an attacker could intercept the email and change it to a 50,000 amount. He can change up to a $50,000. Okay, the receiver has no easy way to know the message was altered or not. DKIM solves this problem by adding a digital signature to every outgoing mail. Okay, what is the digital signature? I will tell you guys in this video. So stay in the video. Okay, so when do we use DKIM? Okay, so you use DKIM whenever your organization sends emails from its own domain, such as Microsoft 365, Google Workspace, Zoho Mail, Cisco Secure Email, SendGrid, MailChimp, and many more. Okay, it is especially important for business mails because you don't want that anyone can intercept in your emails, right? So in those scenarios, it is very important. DKIM very important. Okay, banking emails, OTPs, password reset emails, invoices, marketing emails, newsletters. So these are the some important areas where DKIM will helpful for you guys. Okay. Now first understand about the hashing. Okay. Why we are going to understand the hashing? Because hashing is an idea which are used by the DKIM. Okay. So let's deep dive into it. So understand the hashing. Suppose the email body is hello Bob, meeting is at 10 a.m. Okay. So a hash function such as sort256 is what? As a hashing algorithm we are using, and it converts it into a fixed length digest. Okay. So email body using sort256 converted into a hash digest. Okay. Even if one character, mark my word, even if one character changes, the hash changes dramatically. Okay. So let's suppose meeting is at 10 a.m. sort256, and this is the hash for that. It will change. What is the difference between these two? What is the difference between hello Bob, meeting is at 10 a.m. meeting is at 10 a.m. hello Bob is not there, so it will change the hash. Okay. So the hash provides a way to detect modification. Okay. So that is how you will detect the changes. Okay. But hash alone is not the authentication also. Okay. This is the important point you guys need to understand. This is extremely important. Suppose an attacker changes 10 a.m. to 11 a.m. Okay. And then the attacker can simply calculate a new hash. So hash is the integrity mechanism, and hash alone does not the authentication, because attacker can also create a new hash. Okay. So after that, if hash is not enough, what we are doing, I will tell you guys. So for that we need a mechanism that prevents the attacker from creating a valid replacement signature. That's where asymmetric cryptography comes into the picture. That's why we guys are using asymmetric cryptography So actually what happened is we need a mechanism that prevents the attacker from creating a valid replacement signature. That's where asymmetric cryptography comes into the picture. So DKIM combines hashing and digital signature. The sender has private key and public key. The private key stays on the sender's mail server. The public key is published into a DNS. Okay. For example, example.com having a DNS selector 1 dot underscore domain key dot example.com DKIM public key. Okay, that's how the public key is published in the DNS. That's a one example I showed you guys. What happens when you send an email? So let's suppose your Alice send the email alice at the rate example.com to bob at the rate gmail.com. Subject is meeting. Hello Bob, meeting is at 10 a.m. The sending mail server performs roughly these steps. Okay, first step, select headers. DKIM does not necessarily sign every header. It might sign from, subject, date to, and the message body. That's it. Not necessarily every header. Okay. Step 2 is has the body. Has the server calculates with the using of a hashing algorithm. Let's suppose SAW 256 email body, and now it will be like it will maintain the body hash. So this is called the body hash. Okay. After that, in a step 3, it will build the DKIM signature data. Okay, the server creates the data that will be signed involving things such as from, subject, date, to, body, hash, DKIM parameter. All these things are there because we are going to build the DKIM signature data. Okay, then it cryptographically signs that data using the private key because sender have its private key, and he will publish its own public key into a DNS records. Okay, so conceptually what is happening here is sign data with the help of the private key and it will become the digital signature. Understand guys? Now the step 4 will be add the DKIM signature header. So this is something like server adds some DKIM signature header, and in this we have some important fields. Which do you understand? Like D is equal to example.com. So D is the signing domain. S here is a selector, DKIM selector. H headers what that was signed. Okay, and BH here ABC123. It's a body hash which is created with the help of the hashing algorithm, and B XYZ78 like something is written over there. It's considered as a digital signature. Okay, guys. After that, step 5, receiver receives the mail. Okay, now your Gmail, Outlook, etc. Okay, receives the message. So the receiver sees this DKIM signature, DSBHB, everything. Okay, it needs the public key, so it performs a DNS lookup. So it will perform the DNS lookup to this DNS. So DNS returns the public key because the sender have published its public key into a DNS records. Okay, so after that, in step number 6, what receiver will do? Receiver calculates the body hash again. Okay, whatever sender has sent has, it will recalculate with the help of this data, whatever is sender sends. Okay, so receiver calculates the body hash again, and this is the most important part, guys. Again, understand, guys. So receiver takes the received body. Hello Bob, meeting is at 10 a.m. and it calculates with the help of the SAW 256, and it compares with BH ABC120. BH is what I already told you guys. BH ABC123 here is there. Okay, in the fields which I show you, BH is a body hash, so it will maintains the body hash and then it will compare from the DKIM signature. If they match, then what will happen? DKIM body match, then the body has not been modified in the signed portion. So that's the overall idea how sender will send the hash and headers and everything, and how receiver will how the receiver will verifies from their own end. So if they don't match, what will happen? Calculator hash does not is equal to DKIM body hash. So then something has been changed. That's how receiver will comes to know. Okay, original, let's suppose example, meeting is at 10 a.m. attacker changes, meeting is at 11 a.m. So receiver calculates new hash 7B40 or something like that, but DKIM says ABC. So hash will not be same. Okay, so DKIM verification fails. Then the receiver verifies the digital. Step number 7. Okay, What is the step number 7? Then the receiver verifies the digital signature even if the body has matches. Let's suppose here body is matches, body has is matches. Okay, then the receiver also needs to verify that the signature was created by the legitimate sender and the domain. That is very important. After matching the hash also, it will match that the legitimate user or the legitimate sender or the domain has sent this mail. So it uses DKIM public key, sign the data, it will prepare signature verification, and now it will verify. First it will verify signature validating will be there. After that body has validating will be there. Okay, so the receiver can establish that the signed content has integrity and that the signature corresponds to domain's published DKIM key. So that's how it works. Okay guys, now I am telling you the whole 8 process, whatever I have 7 processes are there. So in the 8th number I am going to tell you the whole process. Let's suppose what's happening here is sender will send the email with headers. Okay, and now it will hash the body with the help of the hashing algorithm. Let's suppose SOR256 body hash will be prepared. After that what will be happen? Create DKIM signing data, sign using private key. All these things will be done by the sender itself. Okay, DKIM signature header it prepared, then it goes to the internet, receiver will receive it. Okay, it performs has received. Okay, it will compare the body hashes, it will verify the signature through the public key, it will ask about the DNS lookup, it will get the public key and verifies the signature. Okay, if DKIM pass, DKIM fails, these are the 2 results which will be happen. So now understand where is DKIM configured. DKIM uses 2 keys as I mentioned, private key and public key. Private key is stored securely on the sending mail server and it is used to sign outgoing emails and it is never shared. Public key published in a DNS as a text record as I mentioned guys, used by receiver receiving mail servers to verify the signature. This is the DNS record. If let's suppose if someone modifies the case, okay, amount is $5,000, it changes the amount 9,000. Original hash does not is equal to the new hash and the hashes don't match, result DKIM fail. So let's understand the flow what we have covered in this video. So I have prepared a image for you guys. So in this video whatever we have covered is the problem we have understand first, that email can be tampered. Attacker changes email content in transit. How can the receiver know if the email is genuine and not modified? So this problems was there before the DKIM. Email can be intercepted and modified while traveling over the internet. So this was the problem guys before DKIM came. So now enter into the DKIM, the solution. DKIM means what I have told you guys, domain keys identified mails. So DKIM uses cryptographic signature to verify that email is from the domain owner and has not been altered. And how DKIM works, I already told you guys, sender mail server, DNS is there and it will publish public key into the DNS, receiver mail server verifies the signature, receiver get the results. DKIM signs the email with the private key. This is very important. Receiver uses the public key from the DNS to verify the signature. Now DKIM signing process I told you guys. What happens, it creates a hash of email content with the headers plus body, signs the hash using private key and adds DKIM signature header in the email with the help of the private key. So this is what email with DKIM signature. After that what will happen? After that here it will publish public key into the DNS. It is a text record, select a default host. The public key is published into a DNS as a text record. In step number 3, it will be verified as at receiver side. Okay, it will extract DKIM signature from the mail, create hash of the received email, decrypt signature using public key, compare both hashes. Receiver gets the public key from the DNS as shared by the sender and verifies the signature. Okay, that's how it works. After that what will happen? DKIM pass, email not modified, or DKIM fail. These are the 2 results. I told you guys, DKIM pass or DKIM fails. Email modified or email not modified. Okay, in case of DKIM pass, email modified, sorry, DKIM pass means email not modified. Okay, and DKIM fail means email modified. That's why your DKIM fail. So signature does not, in this case, signature does not match. Email may be tampered or spoofed. Now in step number 9, this was the original header, and this is the header after the modification. So even a small change will break the DKIM signature. I told you guys. Okay, DKIM record example. This is a text record, host, value. We are putting the values, version, key type, and public key we are putting inside the DKIM record. Okay, public key helps the receiver to verify the DKIM signature. That's a use case why sender sends the public key into a DNS record. Okay guys, so that's the whole idea about the DKIM. Now let's understand just few things about the DKIM versus SPF. SPF checks who is sending, valid IP or server, and it uses DNS text record. Okay, that's SPF part I have already covered in the previous video. You can go and watch that video first and then come into this video, DKIM. So in this video I have told you guys that what DKIM does. DKIM checks what is sent, email content integrity, and it uses DNS test record. Okay, DKIM content verification, SPF sender verification. So in the next video I will tell you about DMARC and how DKIM, SPF and DMARC work together. Okay, so if all of these things we will combine, then we will have a better email security. So that's for this video. Okay guys, take care, bye bye.